Hi guys, welcome back to our channel, Tech Concepts with May. You remember that in our last video, we have been talking about some important PSQL commands that you need to be cognizant of while working within the PSQL environment and with Postgres. We also demonstrated the concept of creating databases. We ended by dropping the last database that we had created, first store. So we're going to begin from that point. Before I go any further though, I want to please request that you subscribe to the channel, Tech Concepts with Ume, by clicking on the subscribe button, but also clicking on the notification icon so that you can become aware whenever new videos are uploaded. So I'm going to begin by logging into the PSQL environment. So I'm going to begin by saying PSQL user Postgres. It will prompt me for the password and I will enter my password. Now, remember that we had created a database called First Store. So we're going to recreate that database now. So I'm going to say create database First Store. Let's give it another name, First Stores. Okay, and now I get the output, create database, which indicates that our database has been created. Now, note that we're still using the Postgres default database, and we may want to use the database that we have created. Now, to use that database, we're going to have to connect to it. Now, to connect to the database, there are two ways of doing it. You can either say \connect, so this is a long form of connecting, or I could say \c. Either way, I'll connect to our first stores database. So \c first stores. Okay, and now we're not using Postgres anymore. We are using first stores. Now, what we need to note is in creating tables, which is what we're going to primarily focus on in this video, there's a concept which you need to be aware of, which is the schema. Now, your schema is like a logical container that holds all the tables, okay, relationships, constraints, okay, related to a particular database. All right. So really, your schema is like a container. Think of it as a container, all right? And the container defines the structure of data in a particular database, right? So that being said, we're going to create a schema. Well, before we create a schema, let's view what schema we're currently using. Usually, with any database created, especially with Postgres, there's a default schema created alongside. And the default schema is called public. So to see what schema we're currently using, okay, to possibly create tables that we hope to create, we're going to check. Now to check or view the schema that you're using, you're going to use the command show search path. All right. And you will see that we're using the public schema, right? We're using the public schema. We can decide to create our own schema, all right? As opposed to using the general public schema. Now, let's view what schemas exist within our database. So I'm going to use the command \dn, all right? And you'll see that the only schema we have in our database is the public schema. So we can decide to use that, like I said, or we can decide to create a new schema. So just for demonstration's sake, let us create a new schema. So here we're going to say, similar to how we create databases, create schema. Let's call that schema new. Create schema new. All right, and we see that that schema has been created. Now, when I use the command \en again, you see we have two schemas created, new and public. Note, we're still using the public schema, whereas we have created a new schema called new, we're still using the public schema. We can now decide to switch over to our new schema. So to do that, I'm going to say set search path, okay, to new. Right, and you should see the output set, which means we have changed our schema from public or schema in use from public to new. Okay, now we have established that we're using a new schema new. Note, whenever this session ends, okay, whenever we're starting a new session and you're logging into the Postgres environment or PSQL shell again, it's going to revert back to the public schema, and then you're going to have to, change it just like we have done here. All right, so usually when you log in, we'll begin with the default schema, and then you'll be able to switch over. So now that we have that knowledge, we are going to learn how to create tables. We're going to learn how to create tables by creating a simple table in our new schema. So to create this table, we're going to say create table. Note, your tables are your entities. Whenever you hear the interswitch between tables and entities with respect to relational database or databases, okay, just have in mind that they are referring to the same concept. So here we're going to say create table. Let's call this employee. We're going to create an employee table, and our employee table is going to consist of 3 attributes. Your attributes are basically characteristics about your entity. So we have the entity employee, and we have attributes about that employee or characteristics about that employee. Every employee will have a first name. Every employee will have a last name. Every employee will have an age. So we're going to use these 3 attributes for demonstration sake. So create table employees, okay, or employee, open parentheses, first name, that's our first attribute. Now, each of your attributes will also have data types associated with them. Each of your attributes will have data types associated with them. So in this instance, for first name, we're going to use the data type char, which stands for character. Now, your character data type will usually also have a length, okay? Well, it's up to you to determine a length or not. So you may want to determine a length for constraint sake, okay, where you do not want users to exceed a particular character length, all right? Then you will use that function. So let's use that function here. So say first name, data type is character. So open parenthesis, attribute name, which is subjective, okay, based on the user's naming convention. First name, data type, character, open parenthesis for length. For length, we're going to say 50. Close that. Then we're going to say last name. All right. Also character. We're also going to say 50. And then we're going to say age. And your age is an integer because it consists of decimal numbers, okay, that can be incremented. So age, we're going to say integer. And with our integers, we usually don't have length, okay? We just leave it as such. Okay, then I'm going to close my parenthesis. I'm going to end with a semicolon, and I'm going to press the return key. And I see the create table output, which means my table has been created. Now, to view, you know, how my table looks, I'm going to use the command select all. So the star character, the star symbol stands for all. We're saying select all from employee. Going to end up with a semicolon. All right, and it shows me we have 3 columns here: first name, last name, and age. However, our, table has not been populated. I want to mention something before we go ahead, before we go on to create another table. Note that we have various data types. In fact, we have a lot of data types. Now, you may want to view the data types that are available to you in Postgres, okay, for when you need to create a database. So to do that, all right, we're going to use the command \d capital letter T space and the star. And that should give us our list of data types that we have. So you have any, you have character, which is what we had used here. So if you look at that, the character is what we have used. Okay, ABS time, and we have, or absolute time, and we have all of these data types. Okay, so I will allow you to go through those, get familiar with them, okay, to determine what data types you may want to use alongside particular attributes, okay, that will be, included in your database. Now, that noted, the other thing we're going to do is talk about, you know, constraints with our tables. One concept that's very important to note when creating tables is that your tables should have primary keys. The tables should have primary keys because there's a need to uniquely identify each record in your table. There's a need to identify each record or uniquely identify each record in your table. But also the concept of primary keys help us to have or create relationships with other tables. Now, with our example of employee, an employee usually will belong to a department. So if we had another table, okay, called department, and we want to be able to link our employee table to department table, we'll be using the primary key. Also, departments may be associated with varying projects. And if we wanted to link the departments table to the projects table, we'll need some form of primary key, all right? So that concept is very important. And if you note with the table we just created, we did not add a primary key. We just, in this instance, wanted to demonstrate how you will create a table. So with our second example, we're going to be creating a table that also has the primary key component as well as another constraint, the not null constraint, which will help you to ensure that a cell is not left empty or null, all right? in the instance that you want the people who will be using the database to fill out every cell or every parameter, then you will use that not null, constraint as well. So let's create another table. This time we're going to be creating another employee table, however, containing the employee ID, as well as what you may also call the check constraint. So the check constraint, all right, it's a constraint consisting of a Boolean operation where an entry either meets the criteria or does not meet the criteria. It's like a yes or no option. Okay, an entry either meets the criteria or does not meet the criteria. We're going to be using age in this instance. Okay, so an employee who is less than 21, okay, we will not be able to enter that person's information into our table. So let's go ahead. So to create this table, we're going to say create table employee. Let's make it somewhat distinct from the other table we created. Employee A. All right. And then we're going to open parentheses and we're going to say employee ID. Okay, that's our first attribute. And your employee ID is an integer. All right. And we're going to say this attribute is going to be our primary key. This is how we specify what our primary key is going to be. And then I'm also going to say not null, which means for each instance of our employee A table, right, the primary key attribute must be filled. Okay, so that's that. Then we're going to say first name. We're going to say character. Okay, and we're going to give it the length of 50 again, right? But we're also going to say not null, which means first name must also be filled out. Okay, then we're going to say last name. Okay, also character. And then we're going to say 50 as well. All right. And we're also going to say not null. And then we may want to add address. Okay. So say address. Then we're also going to say character. Let's give it 100. And then we're going to say not null. And then finally, for our last attribute, we're going to say age, which is an integer. Okay. And then we're going to add the check constraints. Okay, open parentheses, and then define the constraints. Age, okay, must be greater than 21. Age must be greater than 21. And then we're going to close that again, all right? And then end with a semicolon. And I'm going to hit the return key, which tells me that our table has been created. Now we're going to insert information into our table. We're going to do more on insert in a subsequent video, but we just want to demonstrate, something, especially with respect to the check constraints. So here we're going to say insert into employee A, open parenthesis. We're going to list our attributes emp ID, your attribute listing must be in respective order. Your attribute listing must be in respective order. Employee ID, first name, last name, address, and age. Okay. And then we're going to say values. Now, your value listing must also correspond to the respective order in which the attributes are listed. So here I'm going to say employee ID 1, first name, which will be in single quotes, John, last name, Smith, okay, address 3 now drive, okay, 3 now drive, and what's the last one? Age, age, age is 23. We had omitted something, okay, that's the ID, first name, last name, address, age. Okay, now with that done, I'm going to close that parenthesis, and then I'm going to end with a semicolon. All right, now you see insert 0, 1 as the output, which means that our table has been populated with one record. Now, ignore the 0 here, which is for object IDs. We're not dealing with object IDs here. Object IDs relate more to binary large objects. So more multimedia content, which we're not dealing with here. We're dealing with characters primarily. Okay, so to note or to view our record that has been entered, we're going to use the select command again. So say select all from employee A. And we're going to end with a semicolon. All right, and here you see that our record has been entered. Okay, John Smith now drive for address, all right? And the primary key is 1. Okay, now just before we end this video, we're going to demonstrate the check constraint by trying to insert a second record. Okay, so here we're going to say insert into employee A, insert into employee A, open parenthesis, emp ID, okay, emp ID, first name, last name, address, age. Close that, values. And here we're going to say to Esther, last name Wilson, okay. Address to Ben Drive, okay. And then for age, we're going to say 18. Right. Close parentheses, close or add the semicolon. All right. So you will see here that our employee A or new role for relation employee A violates check constraints. That's due to the fact that we added an age that does not meet that Boolean, criteria. So that being said, we're going to stop this video here, right? In our next video, we're going to be talking a lot about relationships between, our tables and how perhaps that will be implemented within the database. So this is part one of the four-part, you know, series on creating tables. Thank you for tuning in. See you in the next video.